Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
Good evening, everybody. Welcome again. And tonight I want to lead off with a little bit of commentary on that Blue Ghost lander, landed on the moon. A pretty big event, because I've watched a number of these fail that came from private parties, private enterprises. And of course, they always have to have some assistance from NASA, either telecommunications or there's so many aspects to this. But they were a private company and landed on the moon. Now we've had countries, we've had India, China, Russia, the United States, and other efforts that were government funded landing on the moon. In fact, it goes all the way back to the 60s, where the Russians were landing on the moon getting rock samples. They were able to bring lunar rocks back, but of course the odd thing there is that anything on the surface of the moon has nothing to do with the moon, because all this stuff is constantly falling down on the moon from away from the moon. And so anything you pick up on the surface has zero to do with the moon. And so the moon rocks, you may as well call them just outer space rocks. And recently, who was it? The latest group to bring back some rocks were the Chinese, I believe, to take some samples. And even if you drill, and you think, oh, well, maybe you could drill down a little ways. No, you're going to have to go down a long, long ways, much farther than your little drill bit from a little lander, much deeper than what a lander can drill. So the surface of the moon has nothing to do with the moon. Okay, so, but anyway, congratulations to the Blue Ghost team company, as that is a big deal. Let's just put it that way. And that just shows you where the space program is going. The space program is going private. Just to be clear, NASA really has not been back to the moon. And anyway, that's a whole complicated topic in itself. But congratulations. But on the flip side of this now, I was just kind of amazed, I guess I'll use that word to be kind, when I looked at the photographs of this lander. They showed pictures of the lander in orbit, and you could see the curvature of the moon indicating that they were still quite far from the lunar surface. And then they're coming down, and then all of a sudden it's blank. And now we've got a few pictures. There's one of a sunrise, which all you can see is glare. You may have taken it from your grandma's balcony or something of a sunrise. It's just a glare. It doesn't show the surface of the moon at all. And then there's one that shows the shadow of the lander, the Blue Ghost lander, and it looks like slate, just like almost reflective. And here's one of the things that I have said previously, is that I don't think we've really seen the real surface of the moon. And now the India lander that landed on the South Pole, this was about a year ago. I don't know the exact date, but it landed kind of kittywampus, but they were still able to get some photos. That to me was probably the most realistic picture of the lunar surface that I've seen. Because here, just imagine, you have stuff falling in, you have craters, so you have big, big craters, meaning that something large crashed into the moon and created a crater, and who knows when, but the surface is completely covered with pockmarks. And I'll talk about Mars in just a minute, the surface of Mars, and the cratering on Mars. Mars is very different because Mars had oceans, and so you find a good portion of the surface of Mars where the oceans were recently, not billions of years ago, but recently, and there's just no cratering at all. There might be one or two little ones here and there, but a grand portion of the surface of Mars is not cratered. And that means that there had to be been water there that basically erased any cratering and left a nice smooth surface. And then right next to it, where there was higher land, you see a lot of cratering, like on the moon, extensive cratering. And so that means that Mars, of course, sitting out near the asteroid belt, is prime target for asteroid collisions, whereas Earth we're a little bit more removed from that, thank goodness. But Earth has been pummeled, repeatedly from outer space with rocks, etc. And every day, I forget how many tons of material fall in from outer space in the form of meteorites. These little, like pea-sized objects that come in and burn up, and if you're lucky at night, you see some of these. Okay, back to the moon. The moon's the lunar surface. So what would you theoretically expect the lunar surface to look like? And the answer would be extremely rough. Not this nice little thin layer of dust that looks like a warehouse somewhere in southwest Arizona or something. That's not what the lunar surface should look like, theoretically, because all of this material, rocks, boulders, fine grains of sand, everything in between. And so what you do in a statistical analysis like this is you say, well, the smaller particles, there's many, many more of them. And as you get to larger and larger particles, there's fewer and fewer of them. So the number of big craters on the moon, there's few of them. And as you get that were created by fairly large objects coming at fairly high velocity to create that kind of a crater. And of course, we have craters on Earth that we know approximately the size of object that hit. For example, the one near Winslow, Arizona. And so then other craters around the planet. But back to the moon. So what would you expect given this statistical average, this population curve of stuff that's falling in on the lunar surface, or impacting, I guess would be a better word. So anything small that comes in is going to hit and be probably broken apart into finer dust. But the underlying that would be a lot of rocks, a lot of odd-shaped objects that came in from maybe a planet exploding some other solar system or some other galaxy. Who knows where this stuff comes from. But also you have the gravitational field of the moon attracting this stuff as it's flying through outer space. And so the surface, what should the surface of the moon look like? It should look very, very rough, with maybe a little bit of coating of powdery dust on top, but certainly not something you could easily drive a vehicle over. Not something that would be easily traversed, even by foot. And certainly not a perfect quarter-inch of dust on a perfectly flat plane, as we have seen in some photos. So back to the Blue Ghost lander, I was very disappointed at the photography because one of the primary things that all of us would want to see is, hey, what does the surface of the moon look like? Not a single, I repeat, not a single photograph that's come out of the Blue Ghost landing gives you even a remote view of what the lunar surface looks like. And that to me is very, very disappointing. And this is the kind of thing that I would think for PR, from the point of view of the Blue Ghost people, what's the name of the company again? Firefly. I think it's Firefly is the name of the company. And Blue Ghost is the name of the lander. So, but once again, an extremely noble effort, a great result, landing on the moon. That means there'll be many more to come. People will be investing. There will be reasons to invest. There will be optimism for financial investment in the lunar exploration. But if you wanted PR, I would think that you'd want a photograph of the lunar surface. And we have none. We have not a single photograph that shows us what the lunar surface looks like where they landed. Now, they have a package, I believe there's like 10 experiments on that lander from NASA. So clearly NASA is partnering with these people to land on the moon and do some scientific research. Okay, let me quick talk about Mars, and I'll pull up some photographs here. By the way, my book, the Principia Meteorologia, the Physics of Sun, Earth, Weather, is one of my books. It's a book I'm very proud of. This was published in probably 2000 and I'll just say roughly 2004, 2005. It was originally a 600-page book, and I had to trim it down to 300 pages to make it manageable. And it goes through the entire solar system and talks about the weather of the solar system and of all the planets. And in the middle are, I think it's 8 plates of high resolution of the entire surface of Mars. And so hopefully I'll be able to pull up some of these plates and show them to you. But the surface of Mars is very definitely the result of water erosion, and a good deal of water on Mars. For example, around the base of Olympus Mons, you see the kind of it's called sloughing is the geological term. What happens, and let's take a good example of that, are the Pacific Islands, especially the Hawaiian Islands, are eroded on the windward side. In other words, what happens is the waves come crashing in, it erodes the volcanic islands. And the other thing about volcanism in the formation of islands is it's layered. Now, when you have a shield volcano, as you have with Olympus Mons, the biggest volcano in the solar system on Mars, what happens is it's different than a cinder cone. A cinder cone is explosive. You get a lot of cinders, and it makes this cone shape. But Olympus Mons is a shield volcano. It's a separate category of volcanoes made from layers and layers and layers from event after event after event of volcanic flow. And so this is a slow flow of lava down the mountainside. And what happens? When it rains, the lava, the layering of the lava, the water gets down in between these layers and it makes it slick. The water stays in there, and there's tremendous weight on these layers. So what happens is if there's an earthquake, a slight jiggle or something, this entire layer of lava goes sliding off like a giant toboggan off into the ocean. And then there's 2 effects. There's the erosion of the coastline itself, which gives you these cliff formations. And then you have the sloughing, where because there's nothing to hold it, you have to imagine on a hill. Let's just imagine if you cut away the side of the hill, then there's nothing to hold this land up here. And if it's in layers, like in a volcano, there's tremendous amount of weight. And then the fact that you have water in between the layers, causing it to be like slimy mud and a very good viscous surface. And so if there's a little shake, whoosh, that whole thing comes sliding down and creates, in geological terms, it's called sloughing, and it sloughs off into the ocean. Well, you see this on Olympus Mons, which tells you that during the history, recent history of Mars, not ancient history, not billions of years ago, but within 100,000 years, Mars had vast oceans and a weather system just like Earth. And that's what the ancients tell us. The ancients talk about Mars being the blue planet. It's a twin planet to Earth. And the best resource for this is Immanuel Velikovsky in the research he did where he was studying ancient texts. So now let's jump back to the moon for a second. The moon does not have this, as with the planet Mercury. Mercury is very much like our moon. There's no atmosphere. It's just full of pockmarks of cratering due to impacts, etc. But back to our moon. The moon's surface is completely covered with debris that fell in from outside, and therefore the surface has really nothing to do with the lunar history. So you can pick up all the lunar rocks you want. You can send your lander up there to drill in to look for anything you want, but the end result is it has nothing to do with the moon at all. And so people have paid vast amounts of money for moon rocks. Well, I got news for you, boys and girls. They're not moon rocks. They're rocks that were on the moon, possibly, but they have nothing to do with the moon. And so if you can date them, so find some radioactive method of dating or some isotope dating technique or something like that, you're not measuring anything about the moon. And then you cannot infer anything about Earth. The same thing with Earth. The Earth has been layering up over millions, billions of years, and the surface we see now, what is on the surface of the Earth, has absolutely nothing to do with historically what was originally planet Earth. Okay, so once again, my final analysis of the Blue Ghost landing on the moon is, where are the photos? It's like back in there was this commercial when I was younger, and this little old lady comes up, and it's about one of the hamburger chains, and she goes, "Where's the beef?" And that's my comment also, is where are the photos? The number one PR thing that you could do is not show a picture of Earth, because with the cameras they had, they show this little kind of dot up in the sky, and they say, oh, that's planet Earth. Okay, well, that's really good. We've seen those before. What people really want to see is the surface of the moon. Where are the photographs? Firefly Company, where are the photographs of the moon? Let's compare those photographs with what other photographs we have seen of the moon from other sources. Okay, now a number of weeks ago I started a lecture that was regarding what is known as the Betz limit, something that's totally incorrectly used universally in the wind energy industry to determine the amount of energy that can be extracted from the wind by three-blade wind turbines. And I talked extensively about that, and so that is going to be the basis for further discussion. And last week I talked about aerodynamics and birds' wings, comparing birds' wings to wings of airplanes, man's wings, God's wings versus man's wings. And it's very clear that bird wings are far superior in many, many respects. The wings of man, the airplane wings, have a lot of deficiencies when you compare them apples to apples. The cross-section of the wing, the ability to stop the air from flowing down the wings and ruining the airfoil, etc., etc. And so even though man has made feeble attempts to cure the problems with their artificial wings, they're nothing compared to the wings designed by our great creator and for the wings of birds, which are just very, very beautifully designed for what they have to do. Now, this week I was going to talk about all the different types of bird wings, but I decided that it would be getting a little bit off into Neverland for the majority of listeners. A little bit too much detail, a little bit too much information to keep interest levels. And so I'm going to do a very quick summary of that. But the reason I'm talking about, first I talked about the Betz limit and the incorrect use. I talked about the Bernoulli principle and the misuse last week. I hope you, if you didn't see those shows, go back and listen to them or watch them. And so this week I want to culminate all of these discussions and show you what led up to the design of the patented JMCC wing generator. And now this is important because right now in the world, all of the leaders of the world, and especially right now in the United States, there's a lot of upheaval. Whether you like it or not, or whether you think it's good or bad, is irrelevant. It's happening. So put on your seatbelt. But one of the big areas of change is in the area of energy. And so anyway, what I want to get at here is the understanding that I had, this is 25 years ago now, literally, in understanding that the energy industry, the alternative energy industry, what you generally think of as three-blade wind turbines and solar panels, none of these things are going to work. And so shutting those down is a very good thing to do, because the only reason those technologies are in existence, other than maybe putting some on houses, that's always a benefit. But when, in terms of large-scale implementation, for solving the world energy problem, neither one of those will work. And so what I want to do is show you the thought patterns that I went through to design what is known as the wing generator. Okay, so first of all, excuse me, hope I'm not going to lose my voice here for the end of the show. I want to use, a lot of times I use analogies, excuse me, to get a point across. And I worked in the telecommunications industry for about 25 years as a principal engineer. I worked in the design of hardware. I also oversaw software development. I was not a programmer. I was a physicist working for large companies like AT&T and et cetera. In fact, both of my, I worked in two different positions, two different companies, both of them owned by AT&T. This is back in the 1980s. There was a thing called the twisted pair. Now, a pair, there were four wires, and it's basically your telephone wire on the old telephone wires that came into your house, and it was called a twisted pair. And that's when you had the dial-up telephone where you would pick up the handset and punch the buttons, or older versions you would have to actually dial on the phone, where you would dial a number and dial the next number, etc. A lot of people today wouldn't even know what it is. But that's where the term dial your phone comes from. It's one of those historic developments. And so when you say dial a phone, it's referring back to the days when there actually was a dial on a telephone. Okay. But anyway, back to the point of this discussion. In those days, and so I worked in telecommunications, and it was the dawn of the digital age, telecommunications using digital signaling. And so it was then that we developed the protocols, the HTLS protocols that are used today universally. The acknowledgements, the checking of data using acknowledgements and correction codes, etc. And in fact, encryption, it was one of my specialties, was in encryption, making the data safe, how to send it without somebody eavesdropping and picking up your data. Okay, so at any rate, there were mathematical models for the limit, the upper limit of how much data you could send on a twisted pair. These were four little teeny-weeny copper wires that would come into the house from the telephone company and go to your handset. And there was a little cable that looked like an Ethernet cable that people use today. It's a little wider, but it only had four telephone leads in there. It was called a twisted pair. And these were twisted. And so anyway, the calculation, the theoretical limit of putting data on these twisted pair wires going and coming was 9.6, 9,600 bits per second, or a 9.6 as we called it in the day. And so going back and forth, you could double that, and so it was a 19.2. 9.6 times 2 is 19.2. And so that was, and those are kilobits per second. Of course, now everything is in megabits per second, and transmission and data storage is in gigabits. But anyway, back to the transmission rates. The calculated, the theoretical limit based on, and this was based on mathematicians at Harvard University, was 19.2 kilobits per second. And we believed this. And we all just, nobody questioned it, including myself. As a young engineer, I worked with teams. We built complete entire networks, IBM compatible. This was back in the legacy days of IBM mainframes. And going out to like an IBM dumb terminal, these were called dumb terminals. I think it was 270 was one of the numbers of the early terminals. And eventually these terminals, where they had a keyboard and a screen, basically that's what we called a terminal, would have a keyboard, and when somebody would type a key, hit a key, that would send a signal up to the mainframe. The mainframe would then send a signal to the television screen, to the monitor, and put it up there. And eventually these terminals got smarter and smarter, and so when you hit the key, the processor itself would put the letter up on the screen. And of course now that would be ridiculous. But actually we're getting back to this centralized processing with centralized cloud processing and memory, in which, for example, on your new phone, you don't have that much memory. You don't have that much processing power, because a lot of this is done out of your phone or out of your computer or laptop. Okay, so the 19.2 kilobit per second reigned supreme until one day some inquisitive young engineers, I don't know if they were young, I don't really know who came up with the frequency division multiplexing on this twisted pair. And what they realized that is, if you cut the frequency of bandwidth that you could transmit on this set of cables, these twisted pair wires, put filters, frequency division filters in there, you could divide this, you could frequency divide the twisted pair line into 24 channels. Each channel now, remember the old limit on a single channel on that wire was 19.2, but they were now able to put 64 kilobits on a division and 24 of these, and that added up to a T1, what was known in the day as a T1, 1.544 megabits per second. So all of a sudden you go from 19.2 kilobits per second to 1.544 megabits per second. And part of that bandwidth was taken in terms of transmission protocol, but there was hardware protocols, and then on top of that you had software protocols that did the telecommunications, ran the telecommunication protocols, and if you had encryption, that ran on top of that. So this was a layered architecture, as it was called in the day. But the point being that the theoretical model for the capacity of this twisted pair wire was completely wrong. And everybody believed it and nobody questioned it. The same thing is true in the wind industry. Now, when the wind industry puts the three-blade wind turbines out there, and they go, oh, due to the Betz limit, this is how much energy you can derive from a column of wind. It's completely false. And because the Betz limit is a kinetic energy transfer of a non-compressible fluid, like a hydrodam. Now, I explained this a number of weeks ago, so that's just summarizing what I already explained. But the end result is that you can extract far more energy out of the wind using aerodynamics. And so the reason I went through first of all, the discussion of the Betz limit was to show you that it was incorrect. I then talked about the Bernoulli principle, that it does not explain the lift on a wing. And then I talked about bird wings, airplane wings, and then sails. And that was last week. And now what I'm going to do is culminate all of this and show you the rationale for it's a form of multiplexing with the JMCC wing generator and what happens here. Now, what happens when, just one more point here, when you're going back to the old propeller days or the three-blade wind turbines, when these spin, what happens? The wind comes across the airfoil, and because of centrifugal force, the wind slides down the propeller or the blade, and you lose lift. And so one of the ways of containing this, if you have a properly designed system, is to put a blockage so that now last week I talked about jet airplane wings where they put the little flip up at the end of the wing to prevent that, to prevent the air from flowing down the wing. And also how birds naturally do this, where they have at the end of their wings, especially soaring birds and even little birds. I think I showed a picture of a blue jay that had this same feather construction at the end of the wings, where at the end of the wings they flip up. They're like, they flip up, and what happens when the air is passing through, it makes the air go up and back, and it prevents the air from coming up over the wing and ruining the airfoil, the vacuum that's developed on the top of the wing. I also talked about how the Wright brothers, with their very first flights, they took a plane out. They thought they had plenty of airfoil, plenty of lift capacity on their wing system, and they couldn't get it to fly. It just wouldn't take off. They couldn't get enough wind. So they go, okay, back to the drawing board. So they go back to these guys were building bicycles. And so they understood chains and drives. And so when they hooked the motor on their airplane to drive the propellers, they were using chain drive, just like with their bicycle shop. But anyway, they go back to their bicycle shop and they created the first wind tunnel. And they took a model of their airplane and they put it in their little wind tunnel with smoke trailing, and they realized what was happening is that the air would slide down the wing and come up over the end of the wing and then slide back in and ruin the vacuum on the top of the wing. And so then they made the wings longer. They made them longer and narrower, and then reduced that effect. So they learned that a longer, narrower wing was better. It worked better, even though you didn't have any more surface area and you didn't have any more lift capability technically. You eliminated that problem. And then if you look at a soaring bird, you see that their wings have, the other way birds deal with this, like for an albatross wing, for example, it's pointed at the tip. And so when the air slides down the wing, it just flows off, but there's no way for it to come back up and come back down the top side of the wing to ruin the vacuum. And so anyway, there's nature's design and then there's man's design. But back to the Wright brothers, they take their newly designed wing out, and with a nice gentle breeze coming in at Kitty Hawk, they were able to fly. And so they understood the principle of this principle. Now there's another way they could have done it. In fact, they could have put a box out at the end of the wing and prevented that same issue from happening. But they didn't. They chose to just make the wings longer and minimize that effect. Okay, so with the wing generator, what you have are literally wings that are very similar to bird wings in a cage and rotating so that the lift, the aerodynamic lift, is in the rotary direction, and then it's surrounded by a shroud which prevents the wind from coming off the tips of the sails of the wings and contains it. Now that does a number of things. As this thing spins faster and faster, and the centrifugal force becomes greater and greater on the air column, and the air tries to slide out because of centrifugal force, you get a greatly increased force on the underside of the sail. And then also you get, because of the increased airflow and the air speed there, you get a much bigger vacuum on the top side of the sail. And it's contained by the drum that surrounds the wing generator. So if you look at any of the past designs of wind systems that throughout history, all of these principles were not understood. And so being a physicist, being a person that I've designed electronics, I've designed mechanical systems, I've designed sailboats. One of the things when I was young, I lived in a place where there were a lot of sailboats. And I owned a couple sailboats myself and was very interested in sailboat design. So I designed a sailboat, an ocean-going sailboat, but I changed it. I took what was known as a Tahiti ketch. It's a 30-foot, very heavy-duty workboat, gaff-rigged sailboat, and I didn't have enough time and ability to build a full-scale Tahiti ketch with the 2 masts and a ketch rig. And so I made it smaller into a gaff-rigged sloop. And so by making it smaller, I had to make the beam wider to handle the sail, because the volume of the hull goes as the cube of the linear dimension. And so if you make it smaller, you have to make it wider. And that's why these big ships that you can find, the big schooners, the big clipper ships that were used for transportation before the age of steam, they could have this massive amount of sail on them because the volume of the hull and the ballast goes as the cube of the lineal dimension, and the sails only go as the square of the lineal dimension. So you can put this massive amount of sail on a clipper ship. And so I used these same principles when I designed the wing generator, and understanding that as you make it bigger, you get much more lift out of the, and also because the lift, the radial dimension is growing, and the centrifugal force and on the wind that is sliding up the wing, all of these factors come into play. So as you make something bigger in terms of the wing generator, it works, it goes as the cube of the lineal dimension. And so anyway, just wanted to tell you why I've been going through this 3-show long oration of the properties of wind energy and the misuse of scientific principles in the wind energy industry and in aerodynamics in general, because people simply don't understand them. And I talked about the professor syndrome, or the professors or the people working, especially older men. Women may appreciate this, that men, once they get something in their brain, don't try and change it, because change comes difficult for older people, and that's something that I've, in fact, in spite of the fact that I'm a little bit elderly, I still keep an open mind to a lot of things, because that allows you to make discoveries. If you lock your brains in on something, and this happens unfortunately with too many PhDs, is the last thought they had, the last real thought, the last innovative thought they may have had, happened before they got the PhD. And after that, they entered the realm of, academia or industry. And from there on, they're starting at the very bottom step of the ladder. Even though they got a PhD, they start at the bottom of the ladder, and they are regimented in whatever they're doing, whether they're working on military contracts or in the wind industry or electronics or whatever it is, automobile industry, doesn't matter. People are regimented, and that's unfortunate because science advancement requires someone to be completely out of that mode of thinking. Okay, so just to summarize, the wing generator has all of these factors, this understanding mixed in, and allows it to extract energy from the wind. And the future of all of this is in terms of generating hydrogen, because hydrogen can be used as a battery. So with the wing generator, you don't need batteries. Whereas with 3-blade wind turbines that are variable, and especially with solar, you need batteries. And so that's one of the big expenses. That's one of the things that prevents those from being viable alternatives to viable alternative energy sources. In my book, the one I just showed recently, just a little while ago, the Makani wing generator, the world energy. I'm sorry, I was showing the weather book earlier, what I call the Principia Meteorologia, the physics of sun-earth weather. But another one of my books is called Makani Wing Generator World Energy Project. And in there is a chapter on the myth of alternative energy. And this is based on lectures I was giving around the year 2000, projecting that there would be a grand failure in the alternative energy industry with three-blade wind turbines and solar, and that has now come to pass. Okay, changing gears a little bit here, and I don't really like spending that many weeks on a particular topic, but this topic of wind energy and understanding it was really important. I'm going to switch gears now and talk about the Great Flood. Now, this is something that there has been so much misinformation recently that it deserves a real good explanation, and a very clear explanation. When you read the description of the Great Flood, it was torrential rain. Now, it was a torrential rain, and they say lasted 40 days and 40 nights. And I've explained this before about that number 40. The number 40 was used a lot in the Old Testament and the New Testament, where they talk about 40 days, 40 nights, something like that. Christ went into the desert, or the Great Flood. 40 was like their number million. It was a number so big that the average mind could not comprehend. So when you said 40, it was like, wow, that's really a lot. So it doesn't mean literally 40. It just means, like, if somebody like Carl Sagan was famous, they actually made fun of him a little bit because he would go billions and billions, and that was just a number that was so big that nobody could imagine that number. And so that was the term 40. The number 40 back in the ancient days was just a number so big that you just couldn't count that many. It was an uncountable number, because most people, might have trouble counting up to 10, the number of fingers in the hands, or the number of fingers and toes. They might get up to 20. But after that, they're lost. So that was twice as many as most people could count on their fingers and toes. So anyway, that was an explanation of the number 40. But it was 40 days and 40 nights of torrential rain. It didn't come shooting up out of the ground. It wasn't due to an ice dam that broke, and it was a very little localized event. And when you see the historical record, this is one of the other aspects of this that is very important. When you see the historical record, the ancients talk about this from all parts of the globe. It is discussed in the history books, in the annals of history and the annals of humankind, within recorded history. And that is the key. Now, recorded history might go back 4,000 to 5,000 years, maybe 6,000 years if we're lucky. So the traditions handed down that were eventually written don't go back any more than that. So you have people running around, jumping up and down, saying that the Great Flood happened 12,000 years ago. No. It was much, much more recent than that. And they were trying to attribute all of these catastrophes to one period of time. If you go back 12,000 years, there is no written history at all. And there would not have been any written history for literally thousands of years, probably 5,000 to 6,000 years. Was one of the first people long time ago, decades ago, before any of these people ever surfaced, talking about the ancient nature of man in his current form. And that there's evidence for that. I was on the ground myself at archaeological ruins, watching them dug up for the first time and saying, this didn't happen, in the last couple thousand years. This happened thousands and thousands of years ago. And so the ancient cities were clearly, a lot of civilizations probably came in and overtook the cities. That would include the pyramids in Egypt, probably a lot of the pyramids in in Mexico, in Central America. But back to the accounts of written history. The fact that we have written history of the Noah's flood, what we call the Noah's flood, it was a worldwide flood, and torrential rains. Now, if you look at the ark that was built by Noah, and we have the dimensions, we have the physical makeup of the ark. In fact, I did a show one time on because I'm very familiar with boat design and how boats were built. It's a technique called building by eye, where you build you lay out the keel, you lay out the bow and the stern, and then you put in the mid-rib section. And then you fare the mid-rib section give it a nice round shape coming into the bow. And you do this with fairing battens, little thin pieces of wood. And then you start building in the bow sections, the rib sections, literally. And then you start filling in between those and constantly adding battens to give you the shape. And now this is what a naval architect does on paper. And now, of course, it's done by computer. But a naval architect would take literally battens of wood and lay them on a drawing table and put them and give the view from up above and the side view and the tail view and the fore view. And I've done this myself, so I know the process. And then you add the sail rig or the motors, the propulsion system. But of course, Noah's Ark had no propulsion. It did not have sails, but it had a big roof, and it was capable of withstanding basically rain. That was it. You look at the design of Noah's Ark, and it was designed to withstand tremendous rain. And so these stories about, it was a flood, there was this ice dam that broke and flooded the Mediterranean Ocean. How absolutely ridiculous. Do you think Noah would build a boat if that's what the Great Flood was? How did he know that was going to happen, first of all? And second of all, if that's all it was, he'd take his family up to the top of the next hill and wouldn't have to build an ark at all. Or the idea that there were these ice dams at various places around Earth that then washed out certain regions, that there were big washes, which you see all around the world. Also, that doesn't explain it, because how come that happened at the same time as this other wash over here? No, it doesn't explain anything. It was a worldwide torrential rain. Well, how could it rain? There's not enough rain in the clouds to account for that. The cause of the Noah's flood was Earth passing through the tail of a large comet, something very predictable, many years in advance. And so clearly someone got the word to Noah and says, hey, this big comet is coming. Earth is going to pass through the tail. There's going to be a massive flood, and you're going to be in it, and you got to save the animals and your family, and you're going to be one of the few people that survives this and starts generating new population. And of course, the Chinese were astronomers. They could have known about this, but the Chinese have mountains. You have India, the Pakistan and the Hindu Kush, where people could survive a tremendous flood for a long period of time, especially if they had forewarning. And so you have to understand, too, that the previous civilizations were very advanced in their knowledge. It's very true that before Noah's flood, there may have been an Earth population similar to what we have today, 7-8 billion people. And the flood killed them all. Almost all of them was a mass extinction. And we have the biblical, that's what the Old Testament is. It's a biblical record. It's a genealogy of the people who came down from Noah and down through, that's what it is. It's a genealogy, and the genealogy isn't long enough to be 12,000 years. So there's many, many reasons why we understand that the Noah's flood happened. I would put it at the outside 6,000 years ago. That was the outside. And it could have been more like 4,000 years ago. We really don't know. And I don't put dates on things. But I can tell you dates that are not correct. And for sure, a date of 11,000, 12,000 years ago is completely bogus, off the wall, and it completely ignores the real data. The Noah's event was within human history, recorded human history. And so that puts it at a limit of 5,000 to 6,000 years ago. It was a recorded event, a torrential rain. It wasn't water shooting up out of the ground or an ice dam breaking or any of these Looney Tune ideas that are floating around today. It was torrential rain. And you see the earmarks of this all over the world. When Ignatius Donnelly wrote his famous book, Atlantis and the Antediluvian World, when the naturalists first came to the North American continent and started working their way west, Ignatius Donnelly was a lieutenant governor of Minnesota in the 1860 period, about the Civil War, period of the Civil War. And they recognized that there was all of this disaster left over from the Great Flood. And the situation was, however, by the year 1900, because of the Industrial Revolution and because the number of people moving into the Western Plains and through the United States, most of the earmarks of the Great Flood had been destroyed by man. And so people started saying, oh, then there was no such thing as a Great Flood. And that's where they are today with the uniformitarianism. But the person who, there are many people, Ignatius Donnelly was one of the people that pointed this out, that there had been a Great Flood, and the earmarkings of this Great Flood were everywhere to be seen. And of course, this was not just the United States, it was worldwide. So the Great Flood was a torrential rain that lasted for weeks and weeks and weeks, day and night. And this is the kind of torrential rain that, for example, I've been in the tropics, where it rains so hard that you cannot even breathe. It's very difficult to breathe. You have to get under something to break the water so that you can literally breathe. That's how hard it's raining. And it causes flooding day and night. Sometimes it rains so hard that there's flooding and the rivers overflow their banks, and there's roads that are washed away, and it's a real disaster. And then the people come back. It only lasts so long, so the people come back and rebuild. But the Noah's flood, the water levels rose hundreds of feet. This is the ocean levels, and this is not the only great catastrophe that happened within recorded history. Another one is well documented by a guy named Immanuel Velikovsky, where I call it the Venus event or the Moses event. Popol Vuh talks about it, the Venus event, the Quetzalcoatl event, you could name it, any of these, but Velikovsky was the premier researcher relative to this. And in that event, with Venus, the comet, we were much closer, and we had tidal waves that actually created mountains. Mountains were built, we had tidal waves, and but it happened much quicker. And so we didn't have that long period of influx of water. There were hydrocarbons, and there are indications that, for example, all of the plagues in the Egypt during the Moses event were caused by the approach of the comet. The electricity into the ground and the causal event of all the vermin coming out of the ground. When we were kids, if we wanted to go fishing, we would take a battery out of the car, and we'd take two wires, one from each lead of the battery, and we'd put these wires down into the ground. And within a short period of time, all the worms would come crawling out. Worms and bugs, everything that was in the ground there would come crawling out. And we'd pick them up and put them in our dirt can, a can with dirt in it, and we'd go fishing. Because we had all the worms. We didn't have to dig for worms. That's how we found our worms. And so the same thing, when the comet came by and the electrical discharges from the comet caused all the vermin to come up out of the grounds. And so that's why you see the plagues in Egypt. You see the red hand of death. I've gone through very serious long lectures on all of these different effects. And by the way, the Tunguska event, I want to make very clear also, I worked with the Russian scientists who were on site at Tunguska. These were the atmospheric scientists that I worked with in the mid-1990s. They were the scientists that went out and explored on boots on the ground at Tunguska. And it was not due to some kind of bolide or object coming in and exploding. That explanation is totally bogus. What happened was an electrical discharge, and that's why they liked my work, because it explained where these electrical discharges come from. But there's, like I say, there's a lot of, I would call yo-yos running around, jumping up and down on the internet, saying that there was some kind of bolide came in and exploded above Tunguska. And that's clearly not the case, because there's no residual, there's no residue from whether it was water, whether it was bolide and rock or whatever, there's no residual. And what is there is the recording of an electrical discharge. But where did that come from? It was a small passing comet that came by Tunguska on that night in, what was it, 1905. Very similar type of event. And the explosion, I've talked about that before, very likely was the lightning bolt kicking off a nuclear explosion just above, and the explosion was very low to the ground, because right off of the ground zero center point, the trees are flattened outwards, which indicates that the explosion was very close to the ground, not miles up into the sky. And then also scorched, the electrical discharge created a tremendous fire, which, as the explosion went out, burned all the trees. It just burned all of the trunks are still there. And that indicates also that it was not a normal fire. It was an explosive event which just blew all of the leaves off the needles off the pine trees, etc. Okay, so back to Noah's flood. The Noah's flood was 40 days and 40 nights approximately of torrential rain. The ocean levels rose, and Noah's Ark was built with anticipation of Earth passing through that comet tail. Now, to give you an example, the comet Hale-Bopp was a medium-sized comet. It was not a big one. It was big compared to modern standards, but compared to the ancients, when they talked about the big comets, we're talking huge comets with nuclei much bigger than planet Earth. But if Earth had passed through the tail of comet Hale-Bopp, it would have taken about 40 days and 40 nights, about a month. And so that's a perfect example of exactly what I am talking about. So in review, the Noah's flood was anticipated because of the comet orbit that was identifiable. The ancients were very good at calculating orbits. Some of them, there were other people, like today, there's a lot of people today that are completely ignorant of, with no ability to calculate cometary orbits. So you see misinformation all the time on the internet about, oh, a comet's going to come in, or Planet X, or all this misinformation about things colliding with Earth. And the reality is that space is a very big area around our solar system, and Earth is just really a speck of dust moving very rapidly. And so these events are very rare, but they do occur. So once again, the Noah's flood was torrential rain worldwide from Earth passing through the tail of a large comet. The Earth's ocean levels rose considerably, and it was not close enough to cause electrical discharges or gravitational effects like happened in the Venus event. So anyway, I hope that clarifies that. And just remember to visit the webpage. You see it up here above my head, and a lot of good information there, a lot of lectures, and a lot of free information. So be sure to go there. And once again, thank you for viewing this show, and tell your friends, neighbors, and as I jokingly say, even people you don't like, tell them to watch this show. Good evening, and we'll talk to you next week.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern, right here on the Bold Brave TV network, powered by B2.